When engineers come from SysML v1 to v2 for the first time, the reaction is almost always the syntax shock. You might find yourself thinking, wait, where are my diagrams? Do I have to become a programmer? Is MBSE just typing now? The short answer for v2, no, you do not lose your diagrams. And diagram-centric tooling and approaches are here to stay. Let's clear up a common misconception right away. One of the most fundamental concepts in SysML is that diagrams are only ever a view of the model, not the complete picture. In SysML v1, because models were authored almost entirely through drag-and-drop diagramming tools, the line between the model and the view often blurred for the user. While some users found it confusing when they hit an element on a diagram but it remained in the model, this ability to remove elements from a specific diagram for clarity's sake is a deliberate feature, allowing modelers to curate views strictly for communication intent. The difference in SysML v2 is how this separation is formalized. Instead of relying on a tool's user interface to simply hide a box on a drawing canvas, SysML v2 builds the separation of model and view directly into the language grammar. In SysML v2, you formally define curated views using explicit language constructs. You expose a scope of the model, apply filters, and strictly render the results into an artifact, like a diagram or table. Consequently, both the textual code and the graphical diagrams are explicitly treated as co-equal projections of the underlying abstract model. This separation isn't just theoretical. It's explicit in your workflow. The architecture enforces a strict, unbreakable separation between the data and the representation. The model, or the abstraction, is the semantic data structure captured in the abstract syntax. However, it is important to remember that the model is not always the absolute single source of truth. The true source of truth is often the documents from stakeholders. A model is a precise abstraction of these documents, whether textual or graphical. Both the textual syntax and the graphical syntax are explicitly defined as different renderings of the same exact underlying model. Because models are abstractions, complex context information and reasoning often do not fit neatly into SysML elements. Good practice dictates that models should always be linked with natural language documentation, where the nuances and details of those design choices securely live. Modern SysML v2 environments, such as SysModeler, utilize a visual-textual hybrid interface. Imagine a dual monitor setup. On the left screen, you type part_def engine. On the right screen, instantly, a part box labeled engine mathematically renders in the diagram pane. This offers the blazing speed of typing with the communication power of visual layouts. Tools strictly enforce synchronization based on the model semantics. If you write a line of code on the left, the diagram automatically updates on the right. Here is an example. SysML v2 standardizes how we define structure semantically. Let's look at how we connect parts and assert identities, explaining it line by line. Here, we are defining the internal architecture of a spacecraft. We start by declaring its internal parts, a payload and a bus. Then, we define how they relate using a connector to physically wire a data path between these two parts. And we use a binding to mathematically link the payload's mass to our overall mass budget. In v2, we must be incredibly precise about the nature of a relationship. This is where v2 outshines v1 mathematically. This code physically or logically wires a direct path for data, named dataflow, to travel from the payload, which is the source, payload.dataout, to the bus, which is the target, bus.datain. The syntax here is that you write connection, then you name the connection, then you write connect, then you write the name of the source, and then you write to, and then you name the target. This represents a physical or logical path for flow or interaction. Some examples could be a copper wire transmitting voltage, a pipe moving fluid, or a network link passing data packets. Now we come to the binding or the identity. This code mathematically asserts that the payload's physical mass from the source payload.mass and the spacecraft's mass budget, which is the target payload mass budget, are the exact same property. The syntax here is bind space source =, target. This means two usages refer to the exact same entity. An example of that could be a logical sensor port on a software diagram is bound to the physical sensor port on the hardware diagram. Tools read the abstract syntax derived from this text and auto-render a structural topology view. You will see a large boundary box, which is the spacecraft. Inside it, three smaller boxes appear, which are the payload, the bus, and the payload mass budget. A solid line, often with an arrowhead indicating direction, connects their respective ports, labeled data flow. This visualizes the physical or logical wire. The tool will render a distinct binding line standardized in SysML v2 graphical notation as a line with an equal symbol in the middle, connecting payload.mass to payload mass budget. This visualizes that these two properties are the exact same things. Now let's come to why this is better than v1. Standardized API and readable diffs. While SysML v1 tracked changes via machine-readable XML files, SysML v2 introduces a human-readable textual syntax. When used alongside the new dedicated SysML v2 API and services, which standardize how repository servers handle version control, engineers can track precise semantic changes at the code level, making peer reviews much more intuitive. Formalized View Definitions. In SysML, the ability to hide elements from a specific diagrams is a feature for clarity. However, SysML v2 removes the ambiguity of how views are created. Instead of relying on manual UI clicks to hide elements, views can be explicitly defined using rigorous expose and filter statements. This makes it instantly clear whether an element was excluded from the view by design or deleted from the underlying model. The power of auto-generation. While manual diagramming remains a vital, fully supported part of SysML v2, you are no longer strictly forced to draw diagrams to establish your architecture. You can spend your mental energy defining logical and structural connections natively in text and rely on the tool's rendering engine to auto-generate graphical projections based on the semantic relationships you defined. Let's wrap up this lesson with a quick v1 versus v2 cheat sheet. If you remember nothing else, remember this. In both SysML v1 and v2, the underlying formal model, not the diagram, is the rigorous source for the system architecture, though the ultimate source of truth often resides in stakeholder documents. While v1 relied primarily on graphical tools to build this abstract model, v2 introduces a formally standardized textual notation alongside the graphical one. However, diagram-centric tooling is not a thing of the past. Rather, text and diagrams are now explicitly co-equal, synchronized projections of the exact same data. We also have not thrown out XML files. While the new textual syntax is human-readable, SysML v2 still fully relies on XML and JSON for tool interchange, and utilizes a powerful standardized API for repository management rather than just relying on standard software version control. Finally, allocations have not been replaced by bindings. Both are distinct, mathematically grounded connections in SysML v2. Allocations map realizations across different structures, while bindings assert strict equivalency between features. In SysML v2, whether through text or drawing, you are building rigorous engineering truths. Next lesson, we are going to tackle the static structure. We will look at how to define the physical architecture, which are parts, attributes, and item flows, using the new v2 syntax to build the Skyzer drone.